Good evening, students. Today I will continue with the next part of the current electricity, that is the Kirchhoff's law. Okay. So I will start with Kirchhoff's law. So according to the Kirchhoff, there are two laws are there. One is KCL, that is Kirchhoff's current law, and second one is KVL, that is Kirchhoff's voltage law. So first I will discuss with KCL, and with that I will continue with this law with an example. Okay. So it is also, this KCL also known as junction law. Okay. It is also known as junction law, and it is the first law of Kirchhoff's law. It states that at the junction, sum of current entering the junction is equal to the sum of current leaving the junction. Sum of current entering the junction is equal to the sum of current leaving the junction. Okay. So now the thing is that what do you mean by this word junction, right? So junction is any point in the circuit. Junction can be defined as, junction is any point in the circuit. Okay, clear? Now suppose it is a point which is considered as junction. Suppose if I draw like this. Okay. So I1 is there. This is the point A. This is junction point O, right? I2 here. I3 here. I4 here, and I5 here. Okay. So here look, I1 and I2 are entering here. Clear? And from that point, from this point to O, I3, I4 and I5 is leaving. Okay. So according to Kirchhoff's law, or according to KCL, it is saying that I1 plus I2 should be equal to I3 plus I4 plus I5. In general, you can write I in, that should be equal to summation of I out. Summation of I in, that is equal to summation of I out. So it is the in general formula of KCL. Clear? Now a problem is there, questions, and with this question solving, by solving this question we will continue we will better understand how we can solve the problems. Okay. So now suppose a circuit is there. Sorry, here one resistance, another resistance. Okay. question is, determine the value current in 40 ohm resistance. Clear? So through this resistance I have to find out the current. Okay, so I will first apply the KCL to this network. How we can apply? Suppose this is the current I is passing through this. Clear? When here it will come through this, it is I1 current will be there, right? Through this junction. And what will be the current in this junction? This will be total current is I. So here will be I minus I1, right? Now consider this. Let us consider that here the current is I2. Now again I am getting another junction. So here the current is suppose I2. So here current will come. So here the current will be I1 minus I1 minus I2. Clear? And whatever the current is passing through this, suppose here I2 is coming, from here I am getting I1. So let us consider this is as I2 plus I1 plus I2. From here I2 is coming, here I1 is coming, so through this I1 plus I2 will come. And in general, if I add this, whatever the current will be here, it will be again I. Clear? So, for the circuit A, B, D, A. First A, B, D, A. This part. I am applying KCL in this part. Okay? So, writing apply KCL to circuit A, B, D, A. Clear? That is summation of IR, that is equal to summation of EMF. In general, according to the what I can say, Ohm's law. So here first here, that is 10 into I minus I1 plus through this I am sorry, and one thing is that I am considering it anti-clockwise. When I am considering anti-clockwise, it will be considered as positive direction of the current, and where I am considering then this is the clockwise rotation. When the clockwise rotation, then value will be positive, and the direction will be positive, and when it is anti-clockwise, it will be negative, right? So I am starting here from A to B. So the voltage drop will be this. Now considering B to D. So it is in the same direction. So that's why 40 into I2. Now the current should be go like this. It is a loop, as I have considered this as a loop. So current should be go like this. But here what I am seeing, here the current is moving in this direction. So that's why I am considering it as minus. So minus 20 I1. So 20 I. Clear? Initially I am considering it at 20 I. So it will be total 0. Clear? No voltage is there, no voltage is there. Basically, that's why by simplifying this, what I am getting, sorry, it will be I1, I think. Yes. 30 I1 plus 40 I2, that will be 0. So it is my first equation. Clear? Now I am applying BCDB. So when I am applying KCL here, same thing, starting from B. So 30 into I minus I1 minus I2. Here again it will be considered as minus, because the current direction from here will be this, but here it is in the opposite direction. That's why minus 15 of I1 plus I2. And here again the direction is opposite direction, current is flowing in direction, but I am considering in this direction. That's why it is minus 40 I2, that should be 0. Again 30 I1, I minus 30 I1 minus 30 I2. And here 15, that will be 45 I1, and it will be 15 plus 40, 30, 40, 70, 70, 85 I2, that will be 0. Clear? So this is my equation 2. Now applying KCL to the circuit A, B, C, E, A. Okay, in the whole circuit. So here total. Next, so it will be I1 into 20 plus I1 plus I2 into 15, that should be equal to 2. For this one, okay? Here 2 volt is the voltage drop. So what I am getting? 2I1 plus 15I1 plus 15I2, that is equal to 2. So 35I1 plus 15I2 equal to 2. So if I solve these three equations, so from here I am getting I1 plus I2 by solving or eliminate any of these two, or I just eliminate this I here from here. Whatever you want, you can do this by solving these three equations. Whatever we are getting basically, please check. That is total I will be 87 by 785 ampere. I1 will be 41 by 785 ampere. And I2 will be 9 by 785 ampere. So my question was that value of current in 40 ohm. So 40 ohm the current is I2. So the answer will be this. Clear? So this is the way how we can solve the current, or we can find the amount of current through any circuit. Clear? So today I am ending my video with this. In the next video I will continue with the KVL part. Okay, so I think after this KVL, your another three things are remaining, that is Western bridge, meter bridge and potentiometer. After that your current electricity part will be completed. Okay, so thank you.